These are my hands, and they may look like ordinary hands, 5 fingers, a couple lines. But what if I told you that these hands are unique to me and me only, and no one else in the world has them? Fingerprints. These little patterns on your fingers are unique only to you. That's how you can unlock your phone, verify your identity, or even solve crimes. They are personal, reliable, and unique. But fingerprints are not always perfect. Things can get a little messy, distorted, smudged, and blurry. These kinds of fingerprints are hard to put a match to, but that's the problem that I set out to solve. Fingerprints are the most reliable way to identify someone because no two are alike, not even identical twins. Fingerprints form before you're born and stay with you until the rest of your life. And there are three main types of patterns: loops, whorls, and arches. But it's not just the big shapes that matter, it's about the tiny details. Where the ridges of your fingers split and end are called minutiae. And minutiae is exactly what my fingerprint matching system uses to find a match. Before we dive into the specifics of how I built my fingerprint matching system, first, here's a simple flowchart for you to understand. First is the fingerprint upload. The process begins by uploading a fingerprint image into the system. This is the input for everything that follows. Second is the image preprocessing. This system cleans and enhances the fingerprint image to make the details clearer and easier to analyze. Third is the minutiae extracting. The system identifies the unique features of the fingerprint, like ridges and patterns called minutiae points. These are what make every fingerprint unique. Then comes the most important step, matching. The system compares the extracted minutiae against a database of fingerprints. If a match is found, the system calculates the accuracy and confirms how closely the fingerprints match. If no match is found, it provides an output saying that no valid match was found. If a match exists, the system displays the matching fingerprint and the score, which indicates how confident the system is about the match. If no match exists, the system highlights the closest fingerprint without a valid match. In simple terms, a fingerprint is taken, cleaned, analyzed, compared, and either matched or flagged as unmatched. In real life, fingerprints aren't perfect. They can be distorted, blurred, smudged, faint, and the list goes on and on. So cleaning them up is the first step to find their match. This is the Python code of what I use to pre-process the smudged fingerprint. Here's the code we use up to clean up the fingerprint. We start by importing some helpful tools called libraries. Think of them as special tools in the toolbox that help us do specific tasks. The first tool is CV2, OpenCV. This helps us with images. The second tool, numpy, is used to handle numbers and data efficiently. Next, we load the fingerprint image using this line of code. This just means opening the fingerprint image so the computer can read it. cv2.imread_grayscale tells the computer to load the image as a black and white because black and white is easier to process for the computer. Now, we want to make the ridges in the fingerprint stand out more, so we use something called CLA-HE. It adjusts the brightness and contrast of the image in a smart way. It's like a smart filter that adjusts the image, and the clip limit and tile grid size are settings that control how the filter works. These numbers are like the strength and size of the filter. After this code, the dots that will form on the image will represent the key points or the minutiae and make this fingerprint unique. This is what we'll use to compare the fingerprints later. Here's the code for detecting those features. We use a tool called SIFT. Think of SIFT as a pair of super detailed glasses for the computer. It helps it find and focus on important points in the fingerprint. These points are marked with dots, which show where the ridges end or branch out. The computer uses this to understand the fingerprint. Imagine you're looking at a map. The key points are like the landmarks on the map, big, important places the computer uses to identify where it is. After we run this part of the code, the computer will create dots on the key parts of the fingerprint, like the minutiae. This is what our computer will use later on to find the perfect match. Essentially, matching fingerprints is like playing a game of connect the dots with your computer. After you find the key points like the minutiae, the computer will compare the input fingerprints key points to a database, and this will essentially find the perfect match for your fingerprint. Now for matching fingerprints, which some might say is the most important part of the code. We use a tool called FLAN, a fast library for approximate nearest neighbors, to help with the matching. It takes a look at all key points we found earlier and tries to connect similar ones from different fingerprints. Index underscore params and search underscore params are settings that control how the matching works. And the flan.knn match compares the key points in two fingerprints. It finds the closest points and stores them as matches. Each line represents a match. The more matches we have, the higher confidence we have in the result. But how do we know that if a match is reliable? This is where accuracy comes in. For each match the computer finds, it'll create a similarity score. The match that has the highest similarity score is what the computer will display as the best result. To calculate how accurate the match is, we count the number of good matches, then calculate it as a percent base scored on how many matches we were found in all the possible points. Good underscore matches is a list that scores matches where the points are similar enough to be considered correct. The accuracy function calculates the accuracy by dividing the number of good matches by the total number of points in the first fingerprint. This score tells us how well the first two fingerprints match. For example, if the percentage is 85, that means the computer is very confident that the prints were for the same person. Now that we know what the code is, let's run the code and see what is the best match for this fingerprint right here. While the computer showed the right match this time, this isn't always the case. Though fingerprint matching is highly accurate, computers can still make mistakes. Things like poor quality prints or bad processing can sometimes create false matches or errors within the system. And there is a lot of technology that's coming into place that may help improve this. Biometrics like fingerprint matching are game changers in technology. But what is biometrics? Biometrics is using unique traits like your face, fingerprint, voice, or iris to identify individuals with high efficiency and security. In fingerprint matching, it uses tiny details like where the ridges end and split to identify individuals with a high accuracy. From unlocking your phone to solving crimes, fingerprint matching is changing how we interact with technology right now. It's fast, reliable, and endlessly fascinating. Thank you for watching my video, and I hope this gave you a glimpse into the exciting world of biometrics. If you're inspired, maybe create projects or look into the endless possibilities, or create a fingerprint matching system of your own following this tutorial. I hope you enjoyed, and see you next time. Bye!